is our next lesson on the empirical rule. Okay, so we talked about mean and median and standard deviation before, and skewed distributions. The empirical rule is when you have a distribution that's perfectly, we call it symmetric or normal distribution, right? Looks like a bell curve we've seen before, we're going to call it normal distribution. A few symbols we need to know here. So we talk about if you have a sample of data and the sample mean, use the X bar symbol. That's for the mean. And if you have a standard deviation of your sample, use letter S, the standard deviation. That's for a sample. However, if you have a population, which a normal curve or normal distribution is used for a population, like lots and lots of data, thousands and thousands of pieces of data. Population. So if you have the mean of the whole population of all the data, we use the Greek letter mu. It's M or mu for mu, and it looks like that, kind of like a combination of an M and a U. That's the mean, or mean of the whole population. And then the standard deviation for the population is sigma. Okay. So for our empirical rule, it says that if you have your data and it's normally distributed, which means it's symmetric, then in the middle, that's where your mean and median are going to line up. Okay. If your data is not symmetric, the mean gets shifted towards the skew. So if it's skewed right, then the mean will be more to the right. But if it's perfectly symmetric, the mean will be in the middle. So we'll put population mean right there in the middle. Now, this dashed line here, that's going to symbolize one standard deviation above and below the mean. Right? Standard deviation is a measure of spread, how much data differs from the average of the mean. So this will be one standard deviation, and then we'll do another dotted line, plus 2 standard deviations, and then here, 3 standard deviations. So notice how the curve is shaped. There's a good amount of data between the mean and 1 standard deviation, and then 2 standard deviations. But after 3 standard deviations, there's not a whole lot of area here. So if you're 3 standard deviations above the mean, that's ridiculously good or ridiculously far. It's something that's good. So this would be 1 standard deviation below, and 2 standard deviations below, and 3 standard deviations below the mean. Okay, so your empirical rule, this is where you right now, follows as this. It says that within 1 standard deviation from the mean, 1 standard deviation below and above, 68% of the data is there. So if you have this area, this whole curve, 68% is right here. Within 2 standard deviations, there's going to be 95% of the data. And then within 3 standard deviations is almost all of it, 99.7% of all values should fall within 3 standard deviations of the mean if it's normally distributed. Okay. So with this empirical rule, we can break up these sections now. So between 1 standard deviation below and 1 standard deviation above the mean is 68. Then you cut that in half, it means there's 34% here and 34% here. Within 2 standard deviations, 95%. So you want to find the area of these two. 95 minus 68. Let's see, it's 27, I suppose. Right? Yeah. And you divide that in 2, so we get 13.5% here and 13.5 here. And then again, 99.7 minus 95, so we get 4.7%, so it'll be 2.35 and 2.35. And then these last 2 sections combine for only 0.3% of your data, so it'll be 0.15% and 0.15%. So not much. Okay, these are numbers that you would normally need to memorize or know. You'll be able to look it up for this year, but because of quarantine. But yeah, you want to know these numbers. When we say empirical rule, we're using the 68, 95, 99.7 rule. Again, 68 within one standard deviation, 95 within two, and 99.7 within three. You can actually do some examples of the empirical rule. First question or example, I want to know what percent of data is below the mean. Okay. Well, since it's normally the median is always in the middle, but since it's a symmetric curve, it means the mean is right in the middle. So, well, it's cut in half. So, what percent is below the mean? 50%. Second question. What percent of data is above 2 standard deviations? Let me do 2 sigma, 2 standard deviations above the mean. Okay, so we've got 1 standard deviation here, 2 standard deviations here. I want to know this section, what percent of data is here? Well, your first inclination should be, well, not much, right? If you get an answer that's more than 50%, like, no, it's not 50% of the curve. If you get an answer that's more than 25%, then no, it's not 25% of the curve. It's something small. Well, using our empirical rule, right? From those sections from the previous part of the video, this was 0.15%, this is 3 sigma, this is 0.15%, this is 2.35%. You add them up, you get 2.5%. So yeah, if something is 2 standard deviation, or something is normally distributed, and you perform better than 2 standard deviations above the mean, you're in a company of only 2.5% of people. That's pretty good. And last example, let's go. What percent of data is between 2 standard deviations and 1 standard deviation above the mean? Okay, so we're looking for the area right here. Oh, I'm sorry, I messed up. What percent of data is between 2 standard deviations below, -2 sigma and 1 sigma above? So let's erase this. So looking for this -1 sigma, -2 sigma, and +1 sigma. We're looking for this area. Okay, so that will be, well, within 1 standard deviation is 68 plus this section, which had 13.5%. So 68 plus 13.5, we get 81.5%.